We focused on how we might make 3D modeling and 3D printing more accessible. Currently, one way in which blind people are able to create 3D models is programming, but there is no way of getting feedback. So they rely on sighted mediators, or they can 3D print it, but then it takes hours to get any kind of feedback. So here we were looking at, can we use tactile arrays to get dynamic feedback and allow a blind person to create, design independently, and iterate quickly. We use a 2.5D shape display. It's an array of pins that are actuated, so they move up and down. It's like a pin art toy. Basically, the pins are raised and they can render a shape, a relief at interactive rates within a second.
A lot of other 2D tactile displays have pins that move up and down and have maybe two states. We have pins that can displace very large distances. And what that allows us to do is create an array where we can create a 3D shape that people can actually feel and touch directly with their hands to get information about geometry directly through their haptic perception.
So here we're trying to represent complex spatial information, 3D information, and we're very used to seeing it visually. We weren't sure, can people understand the information just from tactile feedback? There's a lot of limitations with the shape display. Can they still use this in a meaningful way to understand and create?
What really is so awesome is I can view various perspectives of the object, and not just the object in its single state. For example, you can see the bottom of a cup and the top of a cup. So the top would be hollow, the bottom would be pretty solid. And or you can rotate the object, so you have various perspectives that you can tactily view. And that offers greater dimension to understanding the object that you're attempting to make. And that's the same opportunity that a sighted peer would have.
To me, I think the most exciting parts are really hearing and working with this community and hearing the things that they're excited about making.
When an individual successfully completes a project with minimum to no sighted assistance, that great feeling of freedom is one that a person with a visual impairment takes pride and confidence in.
So much of the information that we use in STEM is 3D and spatial, and we really have a huge challenge in terms of making the tools that we use accessible. And I think this work really points towards a future where all of this information is accessible to everyone.
For more, please visit us at stanford.edu.